Hello there guys, and welcome back to another epic Inexorable maths video. In this video we're going to try to calculate the length of a straight line given coordinates, essentially that it starts and stops at. Okay, so essentially guys, again, with all of our straight line stuff we're always considering the coordinates x1, y1 and x2, y2. So this is nothing different. x1, y1 is some arbitrary point. I hope you can see this diagram. I do realise I probably should have drawn it slightly larger, but I hope you can see it. This is x1, y1, this point here. Again, it's an arbitrary point. It doesn't matter what it is. All we know is it just has some x coordinate of x1 and it has some y coordinate of y1. It doesn't matter what they are. It's just there for a formula to be used. Likewise with x2, y2, I'll move over here just in case you can't see. x2, y2 is just a different arbitrary point on a coordinate axis like how we have here. We're defining the distance between them to be just that. The distance, which we're calling d, is literally just the straight line distance from the coordinate x1, y1 to x2, y2. Okay? Now you'll understand why I've made it look a bit more complicated in a second. Okay? So essentially, if this point here has got the coordinate x1, y1, then we can say, well, this is its x-coordinate, it's x1. So this is the part of the x-axis that we're concerned with, x1. Likewise for x2, this point here, yes, x2 is going to be its x-coordinate. Same thing with y1 and y2. Now, in red, I've actually drawn the distance from this point here, this cross, this x1, y1, to this point here that I've just circled or dotted. It must be the difference in the x coordinates, right? It's x2 minus x1. It's this distance, which I've written here. Likewise, for the y coordinate, we have the exact same situation. For the y coordinates, it's this y coordinate minus this y coordinate, y2 minus y1. The reason for that is because, of course, this distance from the dot to x2, y2, this distance here is just the difference in y's. Okay? And now you'll notice we have ourselves a right angle triangle, don't we? The right angle triangle is, of course, the triangle with one side, x2 minus x1. That's one side of the triangle. The other side of this triangle is y2 minus y1. It's this length here. And finally, the hypotenuse of the triangle is d. Okay? And d is what we're looking for. Now, guys, you will remember from GCSE or perhaps even before what Pythagoras' theorem states. It essentially states that if we have a right angle triangle that would normally be drawn with a ruler, but I'm not going to. I know it barely even looks like a triangle. But if we have a triangle like this, if we call this side length A, this one B, and this one C, then as long as it's a right angle triangle, the formula A squared plus B squared equals C squared always holds, okay? As long as A and B and C are like real numbers, obviously. So essentially that's what we have, okay? This is no different. Notice this triangle is basically this triangle, where A is x2 minus x1, B is y2 minus y1, and C is just D, which stands for distance, the distance between the 2 points that we're talking about. Now, to the left of the board, there is some information. It's a really important formula. It is a rewritten version of Pythagoras' theorem. That is all it is. It looks like a big formula. It's actually not complicated at all if you really break down what it's saying, okay? So the distance d, this is basically what I've said, the distance d between 2 points x1, y1 and x2, y2 is just given by the formula d is equal to the square root of the difference in the x coordinates squared plus the difference in the y coordinate squared. The square root is taken across all of it. You might say, where did you even get that from? Well, if we just say, can we agree that, as I've just mentioned, a squared plus b squared equals c squared, and I've just said that like a is x2 minus x1, b is y2 minus y1, and c is d, then I'll rewrite it for you, a squared plus b squared equals c squared, using this, we can also say, in this situation, that x2 minus x1 squared, because that's kind of like our a squared, isn't it? x2 minus x1 is the bottom of the triangle here, plus, and then this is now our sort of b squared, it's going to be y2 minus y1 squared, okay? Because essentially this is one side of the triangle, this is another side of the triangle, okay? It's a right angle, of course. This is obviously going to be equal to d squared, because d squared, where d is the hypotenuse of the triangle. So we must agree that this formula is true. If you are confused how we've got this formula, then maybe just watch the video again, or just consider a, this is a squared plus b, this is b squared, equals d squared, which is the hypotenuse of the triangle, okay? So of course I will, in a future video when we start trigonometry, I will do a video proving Pythagoras' theorem, because almost no one knows how to prove it. Everyone knows Pythagoras' theorem is a really easy concept, but we can't prove it. No one knows how to do it. Well, actually, I'm going to make sure every A-level student that watches these videos can prove Pythagoras' theorem, although it's very unlikely to come up in an exam. I think it's really important. So don't worry about where Pythagoras' theorem came from. Assume that Pythagoras' theorem is true, and then we must be able to conclude that this is true as well. Now, all we have to do to go from here to here is simply square root both sides. So what I'll do is I'll just square root both sides. So, what I'll do is I'll put d, the d squared, I'm going to move it onto the left-hand side, and I'm going to move this stuff onto the right-hand side, so that you can see it's actually identical to the one down here. Okay, so swapping the sides round and then square rooting, we get the square root of d squared is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Just like this. And then of course the square root of d squared is nothing other than d. So d is equal to x2 minus x1 squared plus y2 minus y1 squared, just like this. Okay. And then of course that is the formula. Ta-da! There we go. So as you can see, that's how we essentially get to this formula. Another thing to notice about this formula is actually the x2 and the x1s, it doesn't matter which way round they are. So, and I'll just expand on that in a second. So just looking at it geometrically, it's quite important to say, well, the distance or the difference between x2 and x1 is x2 minus x1, not x1 minus x2. That will give you the negative version of the difference. Now, the thing is, if we end up squaring it, it doesn't actually matter if it's positive or negative. As you know, any number that's negative squared is equal to the square of its positive number. So for instance, 5 squared is 25, but minus 5 squared is also 25. 3 squared is 9, but minus 3 squared is also 9. So it doesn't matter whether we do x1 minus x2 or x2 minus x1. If we're going to square it at the end, it doesn't matter, it won't make a difference. So you actually don't need, if you ever see this formula, x1 minus x2, y1 minus y2, that's fine. That is absolutely fine. Now guys, we will very quickly jump into a couple of questions relating to this. Okay guys, so now we're going to have a look at some questions. So we want to find the distance between the point 0, 1 and 6, 9. And then we're going to also find the difference between, or the distance between -2, -7 and 5, 1, those coordinates. So if you wanted to, you could draw a diagram, you could definitely do that. I think we should do it without the diagram. We should rely on the formula for this one, because this shouldn't be too difficult of a problem. If the problem is more complicated and they start asking you sort of different things as well as this, then I would definitely recommend drawing a diagram. Although for questions like this, you can just plug them into the formula. Don't worry too much about it. Okay, so just using the formula, remember this is going to be x1, y1, x2, y2. So let's just label them. x1 is going to equal 0. y1 is going to equal 1, just like in our previous videos, how we would do this. x2 is going to be equal to 6, and y2 is going to be equal to 9. course, we want to find the distance d between them. Using this formula here, we're going to say that d is equal to the square root of x2 minus x1. x2 minus x1 is going to be the square root of 6 minus 0, and we have to square that, remember, because it's squaring in the formula, plus, and that was 6 here minus 0 because this is x2 minus x1, squared because again it's in the formula, and then of course plus y2 minus y1. So we're going to plus 9 minus 1 squared, and of course we need to take the square root of all of that, all of it, okay? You cannot put this into two different square roots because, well, they're both, everything underneath the square root is being squared. You can't do that. The whole thing needs to have a square root and you need to square these, okay? So some people will say, well, can't the square root and these squares cancel out? They actually can't because they're being added together, not times. So you need to make sure you do this exactly, okay? So d is then equal to the square root. Well, 6 minus 0 is just 6, and 6 squared is 36. So this is the square root of 36 plus 9 minus 1 is 8. 8 squared is 64. So just like this. Now 36 plus 64 is actually 100. So this is equal to the square root of 100, which is actually just equal, obviously, to 10. So the answer to this one, the distance between 0, 1 and 6, 9 in a straight line is actually 10 units. So your answer would be 10 units. You would normally put the word units. You'll probably get the mark if you don't, but it's a good idea, it's good practice to write 10 units as your answer. Okay, now for this one, this is a little bit harder. So let's label everything. x1 is minus 2, y1 is minus 7, x2 is 5, and y2 is 1, okay? Now, let's just use the formula. D is going to be equal to x2, the square root of x2 minus x1, so 5 minus minus 2. So 5 minus minus 2 squared. Because, guys, x1 is negative. We have x1 is minus 2. So the minus is in the formula. It's x2 minus x1. So, of course, we're going to be doing x2 minus minus 2. And, of course, 5 minus minus 2 is just 5 plus 2 because that's a double negative. And then we're going to add, and this is going to be y2 minus y1. y2 is 1, y1 is minus 7, so it's the same thing. It's 1 minus minus 7. I hope that makes sense, and then that's also squared, just like this. And again, minus minus 7 is 1 plus 7. And the square root comes over everything, just like that. Nice. Okay, and then the last step of this, or the last few steps, this implies that the distance d is, well, 5 plus 2 is obviously 7, so this is 49 because it's being squared, plus, and then 1 plus 7 is obviously 8, and 8 squared is 64. 49 plus 64 is 113, so it's the square root of 113, just like that. And of course, we write units on the end as well. Units. You cannot simplify the square root of 113. It will not simplify, so you would leave your answer as that. You would leave it, if it asks for it in exact form, that is the exact answer. It is the square root of 113, which is an irrational number, so you cannot write it in any other way to make it more simplified. That is it. You cannot break it down into different surds. You cannot do anything with it. That is the answer, okay? And that's all you have to do. A few observations I do just want to make before the end of the video is essentially you have to recall what we did here. We did 6 minus 0, 9 minus 1. This is for part A. What would have happened if we did 0 minus 6? What would have happened if we did 1 minus 9? Well, 0 minus 6 would have been minus 6, but minus 6 squared is 36. 1 minus 9 is minus 8. But minus 8 squared is 64. And that's what's here as well. So just like how I said earlier, it is true, it doesn't matter which way round you write these numbers. You can do x1 minus x2, y1 minus y2, or x2 minus x1, y2 minus y1. Or you can mix them up. You can do x2 minus x1 and y1 minus x2. As long as the x's are inside a bracket together, you can't do x2 minus y2 or something like that. As long as you have the x's together, the y's together, and you're taking one away from the other, squaring the whole thing, formula's going to work. So it's all good. You don't need to exactly remember this thing here. The order of x2 and x1, irrelevant. The order of y2 and y1, also irrelevant. Just remember there's a minus sign between them and they're being squared. That's all we need to know. Okay? So essentially this is how you find the distance between 2 points. In other words, the length of a line that starts and ends at 2 different points. Okay? Thank you guys so much for watching. I highly appreciate it, and I will see you in the next one. Cheers.